What if I told you that every message you send, every bank transaction you make, and even your private photos could be intercepted and stolen in seconds? How is your data truly kept safe in today's digital world? In an age where cyber threats are everywhere, encryption is the invisible shield protecting billions of people. But what is encryption and why is it so vital for our security? Whether you're a tech enthusiast, a student, or just someone curious about how your digital world stays private, this is for you. Encryption is the process of transforming readable data known as plain text into unreadable format called ciphertext to prevent unauthorized access. Encryption protects data. Even if someone intercepts encrypted data, it's unreadable without the correct decryption key. So it ensures only authorized users with the correct credential can access the data. So in case of theft or loss, encrypted data remains secure. So encryption does not prevent interception, it prevents the interceptor from accessing the message content. Encryption happens in various scenarios where data needs to be secured. During data transmission, securing data while it's being transmitted over a network to prevent interception, like in cases of online payments and sending emails. Data at rest, encrypting stored data to protect it from unauthorized access, like protecting databases to prevent breaches. Authentication, encrypting sensitive information to verify user identity, like hashing password before storing them in the database. Encryption uses mathematical algorithms and keys to secure data. Mathematical algorithms are procedures for transforming plain text like hello into ciphertext like something D8E3L2. Using mathematical operations, and keys are secret and unique values used in the decryption and the encryption process. There's a couple different types of encryption. Symmetric encryption, the same key is used for encryption and decryption, and asymmetric encryption uses a pair of keys, a public key for encryption and a private key for decryption. When comparing these two types, we can confidently say that symmetric encryption is faster and ideal for securing large amounts of data such as file storage and backups, while asymmetric encryption is slower and is commonly used for securing communication like email encryption. Now let's dive deeper and understand the four key components of encryption. Encryption algorithm. As mentioned before, these algorithms are a procedure for transforming plain text into ciphertext. Keys. If encryption is a lock, then the key is what opens it. The length and complexity of the key directly determine the security strength of the encryption. The longer the key, the harder to break. Protocols. These are rules and standards that implement encryption in systems. Key management. Encryption is only as strong as the key it relies on. Key management ensures that these keys are generated, stored, distributed, and revoked securely. Now that we understand the building blocks of the encryption, let's explore the best practices to protect data in everyday scenarios, from securing files to encrypting online communication. Use a strong algorithm. Weak or outdated algorithms are easier to attack. Implement end-to-end encryption. Ensure that data is encrypted on the sender side and decrypted only on the receiver side. It protects data from being accessed by attackers. Encrypt backups. Always encrypt backup files to prevent exposure during breaches or theft. Backup files often contain sensitive information and are a prime target for attackers. Use secure key management. Poor key management undermines the effectiveness of encryption. Enable full disk encryption. Encrypt entire storage devices, including operating system files, to protect against physical theft. It ensures even if a device is stolen, the data remain inaccessible without proper authentication.
Khwarizme. Learn to lead.